In this exercise, we will show how to create and rank fault bodies from fault discontinuity attribute volumes. This model requires an OpenDetect Pro and fault and fractures licenses. Open the fault and fracture model from Processing, Fault and Fracture 3D, or from the icon. In the Fault and Fracture 3D Control Center, select the plane's model, Voxel Connectivity, then go. This first step defines the input cube to the workflow. So we go to Select and select the fault likelihood thinned from the SMF size and OK. You can set a name for this first step or keep the default with the name of the input cube and OK. The Voxel Connectivity Filter window pops up where we define the parameters to be used for the extraction of the fault bodies. The fault likelihood input range from 0 to 1, with 1 being the maximum likelihood of fault. Therefore, change the keep value larger than and set the value to 0.6. Set the body size threshold to 100. Keep as output body size, rejected output and defined value. Call this step extract fault body, for example. Voxel Connectivity Filter creates continuous body based on amplitudes of a stored volume. Notice that the voxel is defined as the volume around one sample, and it is linked to the survey bin size and sampling rate. Okay, on the second step, in the Volume Builder main window, specify a name to the Volume Builder setup. Call it Extract Fault Bodies, for example. Ensure the Process on OK box is ticked. You can save and retrieve the setup using the two icons here. Then OK. By default, the active Volume Builder setup is selected. We can reduce the volume to process by going to the volume subselection. Specify the inline range between 120 and 400. Cross-line range 350 to 600, and finally the Z range between 1400 to 1848 and OK. And specify an output cube name, for example VCF ranked fault bodies, and press OK to process. The process finished, so we can close all the different windows. To display the created volume, right-click on the volume in the tree, Add. This adds a volume viewer to the 3D scene. To set the viewer to the range specified during the creation, right-click on the volume and display position. Then we set the range inline 120, 400, cross-line 350, 600, and Z range 1400 to 1848 and OK. Then we select the volume we just created under Stored, VCF ranked fault body and OK. Specify a color bar, extreme for example. We can adjust the transparency as needed and set the undefined transparency to 100% and OK. Zoom in. Display time slice. Right click on Z slice. Add default. and move the time slice to the area where we have extracted the fault bodies. Change the color to grayscale. This concludes this exercise where we show how to create fault bodies from a fault discontinuity attribute volumes.